This lesson is on angles of triangles and quadrilaterals. And so the essential question is, how are the interior angle sums of triangles and quadrilaterals related? We're going to be looking at how many degrees we have total altogether in a triangle and also in a quadrilateral. Remember, a quadrilateral is a polygon that has 4 sides. So if you look at their example here, Nell tore the corners at each vertex of a triangle and arranged them as shown. What does Nell's arrangement indicate about the sum of the angle measures? Write an equation that represents the sum of the angle measures. So if you look what they did, they tore off the corners and they arranged them like this. So let's see if we can make an observation about what's happening here. So something we might observe is when we put these together, they fit right next to each other. And if you look, they actually are forming a straight line with these angles. So if we think about this, if we kind of go backtracking a little bit, a couple things we can talk about, a couple different ways we can talk about this. First of all, if we have a circle, you might remember in a circle we have how many degrees? 360 degrees, okay? So 360 degrees in a circle, in other words, if I would split that circle in half, I had 360 degrees. If I take half of that, is 180 degrees. Okay, what that's telling me is that a straight line is 180 degrees. Now, a different approach to getting to the same thing would be if you guys can think about a right angle. So if you have a right angle, it's like a 90-degree angle. And then if you actually put another 90-degree angle right next to it, that makes a straight line too, doesn't it? We know a right angle is 90 degrees, so 90 degrees and another 90 degrees is 180. Okay? So either way you look at that, we can see a straight line is 180 degrees. So that's what happened with their triangle here. And actually, that's going to be the case for any triangle. If you guys cut out a triangle and tore the corners off, you could actually test this yourself. Your angles, these vertices, these corners, this would make a straight line, meaning that our angles add up to 180 degrees.
Wait, from any triangle?
From any triangle.
It's not equal.
Mm-hmm. So if we look at this in with our example 1, this kind of is what we were just talking about, this generalized box. So you can circle that, highlight it, or put it in your notes. The sum of the measures of the interior angles of any triangle is 180 degrees. So like I just said a minute ago with that other triangle we were looking at, actually for any triangle, the interior angles add up to 180 degrees. So if we look at their problem here on example 1, we have a tile setter cutting tiles. They want them all to be the same size and shape. And the question is, how can the tile setter determine the measure of angle 1? So if you look at their picture here, you can see on their triangle they've got two 65-degree angles and then an unknown angle. Well, the deal is, like we just talked about, we know we've got 180 degrees total in our triangle. So if I've got 65 degrees and another 65 degrees, that's 130 degrees used up. This triangle, no matter what the triangle looks like, any triangle only has 180 degrees total. So that's 130 degrees used up.
That would be 50.
That means we have 50 degrees left for our other angle. Good. So this is one way you guys can do this. I'm just showing you that option is a little bit different than what the book's doing. We'll look at in just a minute here. Okay, again, you can show seeing basically how many degrees do we have used up, and then seeing how many degrees do we have left, which in this case would be 50 degrees left. Okay, if you look at what the book did, they actually wrote an equation. Now, in with this, when they're going to write an equation, they've got this thing here that we may or may not be familiar with. It says find M angle 1. M angle 1 means measure of angle 1. So if you see that, that's what they're meaning. They want us to find what that angle measure is. So a little bit different take what the book did. They wrote an equation, angle 1 plus 65 plus 65 equals 180. And then they added 65 and 65, they got 130. And then they subtracted 130 from both sides, and then they got the 50 degrees. Again, if it doesn't specifically say you have to write an equation, you don't necessarily have to do it this way, but just wanted to explain what they were doing there. So to try it, we've got a similar story. They're wanting us to find the measure of the unknown angle in this triangle. Again, like we talked about, we know we've got 180 degrees total in a triangle. So go ahead and see how many degrees we've got used up here, and then see how many degrees we have left for our third angle. So the first thing here, trying to see how many degrees we've got used up, we can add our 68 and 40 together. So when we add those together, we get 108 degrees, which means we have 108 degrees used up. And again, we know we have 180 degrees total in our triangle. So we'll take 180 minus 108, which is 72 degrees. Good. So 72 degrees would be our missing angle there. A way to check this, we could just make sure when we add those angles should add up to 180 degrees. The convince me kind of goes along with that. They said, could a triangle have interior measures of 23 degrees, 71 degrees, and 96 degrees? So how would we figure out if that would make a triangle or not? So we would just add these three angle measures together here. So 23, 71, and 96. And what we're doing is, if it's a triangle, they would add up to 180 degrees. So what happens, we add those together, we get 190 degrees, which is not equal to 180, obviously. Example 2, we're looking at a quadrilateral, which is a four-sided figure. What they're pointing out here is, on a four-sided figure, we could split that into two triangles. We know on a triangle we have 180 degrees, so if we have two triangles, we have 180 plus another 180, which would be 360 degrees. So that leads us to our other generalized box for the lesson. So the sum of the measures of the interior angles of a quadrilateral is 360 degrees. Another way we could do this, again, you'll want to highlight, circle that, or put that in your notes. Another way we could think about this for a quadrilateral is, if you guys just think of something like a rectangle. You know, a rectangle has 4 right angles. We know each right angle is equal to 90 degrees, and so we have 4 90-degree angles is 360 degrees. So if you ever forget this, just go back to your rectangle is an easy way to remember. You know, you have 4 90-degree angles is 360, and then from there actually you could figure out for your triangle. For a triangle, well, there's 2 triangles that make up a rectangle, we could say. So if you take half of 360, you would get 180 degrees that we found we have for a triangle. So if we look at example 3, an artist is creating a stained glass design for a rectangular frame. How can he determine at which angles to cut the piece of blue glass? So the blue glass, we can see, is a quadrilateral. It's got 4 sides. The question is, how do we figure out the missing angles? We actually have 2 missing angles here, so it's a little bit more of a problem than just finding one missing angle measure. What we can do, though, might seem a little backwards to us, but we can actually find the missing angle in the yellow triangle. Yellow triangle, we've got 180 degrees in a triangle, so if we add 43 and 77 together is 120, and then you could take 180 minus 120, and you would get that our missing angle on the triangle is 60 degrees. Again, you might say, what does that have anything to do with what we're trying to find? Well, if we can get that to be a 60-degree angle, if that's a 60-degree angle here, then we might notice that that angle and the angle on the blue quadrilateral form a straight line. So if those form a straight line, we know a straight line is 180 degrees. So we could actually then, to find that missing angle, we could take 180 minus 60, which means that angle would be 120 degrees. Once we know that angle is 120, now we only have one missing angle in our quadrilateral here. So we know we have 360 degrees total. So again, like we did on the triangles earlier, we could figure out how many degrees we've used up and see how many degrees we have left. So if we add those together, 320 degrees have been used up. So 360 total minus the 320 we've got used up would leave us with 40 degrees. So 40 degrees would be our other missing angle here. If you look at the key concept, just recapping what we've talked about here, in a triangle, the angles add up to 180 degrees. In a quadrilateral, the angles add up to 360 degrees. If you look at the do you understand number 2, Maggie draws a right isosceles triangle. What are the measures of the 3 interior angles? So it's been a while since we've talked about names for triangles. Isosceles triangle means that 2 of the sides are the same length. Now, not only that, we also have a right angle because it's a right isosceles triangle. So what I'm going to do is start by drawing a right angle. And actually, the only way for me to have an isosceles triangle and to have a right angle is if the sides that are next to or adjacent to that right angle are the same length. So if those sides are the same length, we can create our triangle here. The interesting thing is when we make a triangle like this, when we make a shape, the sides, the length of the sides is determined by the size of the angle across from it. So for example, the side at the bottom here, how long that is determined by how big this angle is at the top. If this angle at the top is smaller, that's going to make the side across from it smaller. If the angle across from it is bigger, that's going to make the side across from it bigger. So the deal is that our side at the bottom is the same length as the side on the side here, on the left side. What that means, if those are the same size, that means the angles across from them would have to be both the same. So essentially what we have here, we have a 90-degree angle. So we've got 90 degrees used up. Means we have 90 degrees left. And in this case, we know that those other two angles are the same as each other. So if we take 90 divided by 2, that will tell us what each of those other angles are. When you divide that out, you should get 45, which means each of those missing angles would be 45 degrees. So the three measures, interior angles, would be 90 degrees, 45 degrees, and 45 degrees. If we look over at the do you know how, number 4, again, this is just a triangle that the angles add up to 180 degrees. So this one we could look at actually would be an isosceles triangle. If you notice, there's two angles are the same there. It means two sides would be the same. But we've got 116 degrees used up. Take 180 minus 116 would be 64 degrees. So measure of angle 3 would be equal to 64 degrees. Similar idea if we look at number 5. Number 5 though is a quadrilateral. So we've got 100 degrees, 110 degrees, and 70 degrees. So we've got 280 degrees used up. In a quadrilateral, we know we've got 360 degrees total. So 360 minus 280 would leave us 80 degrees for angle 4. Number 6, we're trying to find the interior angles of the triangle in the middle of the square. In this one, we've got a little bit of work to do here. Sometimes, instead of looking at what you can't find, look at what you can find. So, I'm going to look at this. I really don't know anything about that red triangle, so I'm just going to look at some things that I know. I know I've got some right angles up here. I know I've got this white triangle is going to add up to 180 degrees. So we've got a 90 degrees and 50 degrees. That'd be 140 degrees. That would leave us 40 degrees left for this angle. The top right triangle, similar story. We've got 90 and 40 is 130. That's going to leave 50 for this angle. If we look at the bottom here, we know we've got a 90 degree angle underneath here. We've got 90 plus the 40 above it. These three angles over here actually are going to be a straight line, add up to 180. So we've got 90 plus 40 is 130. That's going to leave 50 degrees here. Same exact setup on the other side. So that would be 50 degrees. Now we know two of our angles in our triangle. Or you could look at the top. There's three angles there that add up to 180. Whichever way you do that, We've got 100 degrees used up, 180 degrees total. So that leaves 80 degrees for our angle at the top of our triangle.